So we're going to start today with the discussion of differentiated teeth, which we have touched on already, but I want to continue a little bit deeper into what exactly that means. So again, undifferentiated teeth, if we have kind of a comparison here, we can take a look at our reptile specimen. And what we notice about a reptile is that all of the teeth are generally shaped the same. So they all kind of start wide and they come down to a point. And we would infer as scientists, right, that that's used for maybe ripping and shredding of flesh, okay, of their prey. But the thing to note about a reptile, which is different from mammals, is that all the teeth are generally shaped the same, and that's called undifferentiated teeth. So we'll compare that to our mammal specimen here, where again, just to briefly review, we have differentiated teeth on the mammal. And so this is a canine, a dog specimen here. And what we'll quickly notice is that there are different shapes of teeth, and that's called differentiated teeth. So a quick review, we have incisors in the front. Canines is this large pointy one, hence the name canine of dogs there. We get back to premolars near the back of the mouth, and then molars are the big teeth all the way back in the back of the mouth here. And so we can note, the thing to note is that there's different shapes of teeth, and that's called differentiated teeth. So mammal paleontology has been based largely on examining these dental specimens, basically. And so even if there's the absence of a tooth, we can sort of tell the shape of it, or how deep the root is, or how many roots there are. And so a lot of mammal paleontology and evolution is based on fossilized teeth, more or less. And as you may notice when you're biting into a lollipop or a caramelized popcorn, teeth are very resistant to destruction. And so those are also better preserved or well preserved in the fossil record. So it's very advantageous to a paleontologist or an evolutionary biologist that teeth are resistant to destruction, because we can start to think about and hypothesize and eventually theorize about the feeding modes of these different mammals. If we can't directly observe them in the modern day, if we have a dentary bone or a tooth socket even, or a full jaw, then we can really start getting specific about the feeding mode of those specific mammals. So digging a little bit deeper into differentiated teeth, we're going to start with the molars, because the molars can really start to distinguish different groups of organisms and different feeding modes. So we're going to start with a group called browsers. And so if we can take a look here at a bear specimen, actually, we're looking at the molars in the back of the mouth there. And browser teeth can be identified by a series of peaks and valleys, actually. And those peaks and valleys, as you can tell from this specimen, is we have these little sharp peaks on the sides maybe, and then we have some deeper valleys in the middle of the teeth, or kind of running laterally across the teeth as well. But that's the key feature of a browser's tooth, is that we have this series of peaks and valleys. And those are basically used to crush things, they could be used to grind, but largely kind of puncture fruits, leaves, sticks, twigs, and sprouts. And so a browser is often has a varied diet there. So this is a great example of a browser's tooth. So another group of mammals that we can distinguish based on their molar morphology are the grazers. And grazer molars look like a series of ridges, basically. And again, think of the function of those molars there. What their function is to grind up plant material. So we kind of want a rough surface you can grind together and prepare for your stomach, right, for digestion. So here we have a rodent skull, and you can see the presence of incisors here. No real canines. And then we can start to focus in on the molars here. And these are great examples of a grazer molar. And to kind of contrast to the browser molars, we have a series of ridges here. And with the browsers, we had a series of peaks and valleys. So a little subtle there, but as you start to look at the specimens a little bit more closely, you'll see that there is definitely a difference there between the grazer molars and the browser molars. So another example of a grazer's molar is this specimen here. And so if we could just take a look here and compare. So we've already looked at this sample, and one of these teeth is representative of one of these back molars. But again, largely different scale here. But what we could notice from this specimen is that you can see pretty clearly, because it's a little bit worn down, is we can see this series of ridges that constitutes a grazer's molar that are utilized for grinding up plant material. Our last group of mammals that we can identify based on tooth morphology is the carnivores. So carnivores, again, they're going to be eating meat, ripping and shredding flesh. And here we have a canine, again, a dog specimen. And what you'll obviously notice right away is the presence of this long and sharp canine. And that's actually a distinguishing skull feature that identifies a carnivore, is this extension of this canine tooth here. And so it's long and sharp, and you can even tell back towards the back with the molars that those are even sharp. So that's indicating a very specialized diet. These teeth are made for ripping flesh, right? These are predators, carnivores. So just keep that in mind. If you start to identify these sharpened molars in the back, these sharpened premolars, and then definitely the existence of this large pronounced canine, then you're going to want to think that it's going to be eating meat, and that's a carnivore. So I'd like to take a little bit closer look at differentiated teeth and how we can deduce the feeding mode from those specific tooth morphologies. All right, so we're going to start with, again, our trusty canine here. And what I'd like to define is exactly the different types of teeth that mammals exhibit and the function of those teeth and how you can identify them if you find a skull or a fossil. So we'll start in the front of the mouth here with the incisors. So incisors generally have a single root, and they're used for slicing, or basically cutting through, biting into maybe an apple or something, right? Or a nice peach. So that's what those incisors are for. They're slicing into something, biting through food. Moving back towards the back of the mouth from our front incisors here, the next tooth that we would identify is the canine. And again, in this particular specimen, it's long and sharp, it's pronounced, and we would deduce that this is a carnivore here. So again, if we have these long pronounced canines, which usually have a single root, it's usually deeper than the root of the incisors, but if we have this long pronounced canine here, you might start to think that this could be used for a throat bite. That's the kill bite, right? And that's actually a function of this tooth. That's the function of that pronounced canine, is that throat bite. A little scary there, right? All right. But these long and sharp canines, again, are pronounced in carnivores. They can be absent in herbivores. You may not need that throat bite if you're eating grass or some corn, right? So that can actually be completely absent in an herbivore. So just something to note there. Moving towards the back of the mouth from the canine, our next group of teeth are the premolars. And the morphology of these teeth can actually vary widely based on the organism's diet or the feeding mode. So with this particular specimen, you'll notice quickly that they're sharp. And so that's speaking to the specificity of this organism's diet, which is it's a carnivore, and so it's largely going to be eating meat, if not completely eating meat. And so those teeth are very specific to the function that they're needed for. So premolars have two roots. Again, they're molar-like in herbivores and they're canine-like in carnivores. And in herbivores, you got to be a little careful there because the premolars can be hard to distinguish from those grinding molars in the back. So just be aware of that. That differentiation between premolars and molars can be a little tricky with the herbivores. So continuing on towards our trek to the back of the mouth of a mammal here, we're moving on to our molars. So molars can have 2 to 4 roots, so they're anchored in the back of your jaw there. And again, the morphology of those molars can be used to distinguish between our browsers, our grazers, and our carnivores. And again, here with our specimen, they're very sharp. We've got some high peaks there. They're very, they look like they're ready to cut and tear. And so we're just reiterating our deduction that this is a carnivore here. All right, we're going to continue on here discussing our differentiated teeth. And we're going to think about a very highly specialized development here called the carnassial complex. And the carnassial complex is specific to the order Carnivora, aptly named, I'm sure. Those are a group of carnivores, obviously. And the carnassial complex describes the sort of the occlusion of the last upper premolar and the first lower molar of these animals. So what you can tell, if I can articulate this jaw correctly here, is that the last upper premolar is going to shear by, or kind of splice by, the lower molar. And so instead of occluding kind of surface to surface like that, like most of the other teeth do, they actually cut by each other like scissors, for example. And so alluding to the function there, obviously. So the carnassial complex is specifically designed to slice flesh, more or less. So you can tell that here from our specimen here in the order Carnivora, where that last upper premolar and the first lower molar are occluding sort of differently than the rest of the teeth. They're sliding by each other in a cutting fashion. All right, so one of the convenient features of identifying the carnassial complex is that if you can figure out which teeth are involved in the carnassial complex here, you can actually define for yourself the border between the premolars and the molars, which that can be a little tricky in other organisms that don't have the carnassial complex. And so if you can find which teeth are slicing by each other here, you can identify that upper tooth is the first premolar and the lower tooth is the molar, and that's going to be useful when we put together our dental formulae in just a moment.